Hello everybody and welcome back. We will continue to learn about Java design pattern, and in our previous video we discussed about observer design pattern, we talked about creational design pattern, we talked about factory design pattern, we also talked about protection proxy design pattern. In this video we will discuss about active object design pattern. Here will be the outline of this course. First we'll discuss the theory revolving around active object design pattern, then we'll discuss about components and discuss finally some of the examples. Now, what is an active object design pattern? The active object design pattern is a concurrency design pattern. As you might know, a concurrency is a programming paradigm in Java where you can run asynchronous and parallel concurrent programs with the help of thread. And in Java, for thread you create thread objects and leverage learnable and callable interfaces, right? So if you are an advanced Java developer, then you might be aware of this concept, but you are a beginner, then I would highly recommend you to watch through or study the concurrency concepts in Java, study about callable interface, study about runnable interface, thread class. Once you are aware of those concepts, it would be easy for you to understand this design pattern. So, an active object design pattern is a concurrency design pattern which decouples method execution from method invocation, allowing objects to execute asynchronously. The main idea is that a method call is placed in a queue and another thread picks up the task and processes it, thus allowing the calling thread to continue its execution without being blocked. So basically, with the help of this design pattern, we will be able to do some task asynchronously. I know for now it would be very vague and very not easy to understand where will this active object design pattern be used. Can absolutely understand. So it would be much clearer once we'll look at a real world example and code it in practically. So before we go ahead and code this example practically, let's first understand what are the components involved in this design pattern. So key components of active object design pattern is an active object, the object that has its own thread and executes requests from other thread asynchronously. That's an active object. Then client, the client object is the one which invokes the method on the active object. Then there is a proxy, the intermediary between the client and the active object. It provides an interface to the client and queue request for execution. Correct. We'll get a more clearer picture once we'll start coding all this component in IntelliJ. Then there is a scheduler. This is optional, but this can be used. It is basically responsible for managing the queue of method calls and ensuring that they are executed sequentially. Then there is a method requester which encapsulates a method call. Each request is stored and executed asynchronously. Finally, there is a servant. This is the actual object that performs the work when the request is executed. Right? So these are some of the components, almost all of the components required for implementing active object design pattern. Let's try to understand with few examples. In this, we'll take a real world example of a bank account system. So imagine you have a bank account system where multiple clients are trying to perform operations like depositing money or withdrawing funds concurrently. Using this object pattern, the bank account ensures that these operations are processed one at a time asynchronously to avoid race condition and also provide better latency, better performance and efficiency. So let's dive deeper. We'll do a practical coding of this design pattern. So let's code it in IntelliJ. I'm moving back to my IntelliJ screen now. As you can look at my screen, currently I am pointing to a patterns package and there is a YouTube package. So under this package we will practically code the design pattern that we are looking at right now. Because we are going to look at a real world example replicating a bank account system, first we'll create all the components required for this. So first I'm going to create a bank account interface which will hold all the contracts required for any application. So this would be public void deposit. First will be a contract to deposit the amount, then there would be to withdraw the amount, and it accepts single argument of type double with the name amount, and then finally there is a get balance method which will return us a value of double type, right? So we are done with the interface. Let's create another component. So this basically would be the servant component, and the servant component will be the one responsible for actually executing the business logic. So let's create this. I'll name it as bank account servant, and this basically will implement bank account interface. Let us implement all of this method. So here will be the implementation. Let's add the implementation of all of this method. So first thing first, what we will be requiring for this servant is we'll require a double balance, and initially when this particular servant object will be constructed, the balance would be value 0, right? I'll go ahead and modify all of this method to mark it as a synchronize, because we are looking for concurrency, and in order to avoid any race condition, we need to synchronize all of this method execution, right? So I'll go ahead and add the synchronize keyword at the beginning of all the methods. This will make it synchronize between different threads. Let's now implement the deposit methods logic. It would be a basic logic. So this dot balance would be plus equals to amount. Then let me add a printout statement here. This basically prints out the deposited amount with a newer balance, right? For withdrawal, we'll make an additional check. If the amount entered is greater than, then only you'll add it for subscription subtractor, or else it won't be. Else you will say a message such as insufficient funds, right? So this is a basic implementation of withdrawal method. Then finally we'll return the balance with the help of the get method. Simple. So this is the simple servant component implementation of our bank account system. Here one thing to note is that because we are going to run this on a different thread, and different thread should be aware of all the values or all the values of that particular thread memory, so we mark all the methods as synchronized. It's important to mark those as synchronized, right? If you're not aware of what does synchronization do, you can check it. It's a basic thing. Like whenever a thread runs, it has its own resource like cache memory, right? Cache memory is like an isolated memory, right? So because of this, the memory stored in the cache memory is not accessible to other thread. Because of that, they are not different threads are not able to communicate with each other because of the isolated memory. So in order to make it communicate, so as to know, okay, what is the state of your memory, if it is being changing or not, so that's why we create a synchronized keyword. They add synchronized keyword, right? So that's a simple concept. It uses shared memory. Shared memory will help to use synchronization between two threads, correct? So basically the servant class is an implementing bank account, and the implementation logic is here, correct? Now let's go ahead and create a proxy component. So we discussed proxy component will be the one. We first create an empty class, we'll name it as proxy, and this again will implement the bank account. Let's go ahead and implement all these methods. right? And we learn in the theory part that this active object design pattern has a proxy class which will maintain the list of, or maybe maintain the queue of request, and each request will be processed asynchronously on a different thread. So what is required here is, firstly you need to make a reference to the bank account servant. Let's make this new bank account servant, correct? So our proxy class is having a reference to the servant class so that it can invoke the synchronized methods from it, correct? Now let's create a blocking queue. This will be responsible for holding the requests that we receive, and it would be a blocking queue with a type of runnable so as we can run those methods on a separate thread, correct? Now what will this override deposit and withdraw method do? Basically this methods will make sure that this particular task of deposit is added to our request. So for that, what we'll do is we'll invoke request dot add method from the queue class. Then using lambda expression, we'll pass in the servant dot invoke the servant dot deposit method by passing in the amount. That's it, correct? Similarly for withdraw also it would be the same. Add the lambda expression point out to servants method, correct? So basically this add operation will maintain a queue of requests, and the request would be maintained in a queue, correct? That is it. We have done with this. Both the methods are ready. Okay, for get balance we'll look at it later. Now we are creating list of requests or queue of requests, right? Now in order to invoke it one by one, we'll need to have an additional process request method. So let me go ahead and create a process method. Process request, we'll call it process request, and it won't accept any argument. Try to add a try catch block because it can cause issue when we try to run a threading application. So always good to run it with a try catch block. If there is any interrupted exception error or runtime error, it can be easily handled. So here what I'll do is I'll go ahead and try to implement a do while loop, and in this do while loop it will accept runnable task, and obviously because we are maintaining a list of blocking queue of type runnable, and from the request that we have added below we'll take using a single method, right? Request.take, and it's giving an error. Let's catch this interrupted exception, and then can say thread dot runnable dot run, and the while condition will be while the request is empty, is not empty. The moment the request gets empty, exit out from this loop. That's a simple implementation of a do while loop. And here in the catch block we will say if the execution of the task fail, this dot, basically it should be thread dot current dot interrupted. So if, because this will be running on a different thread, if this thread gets an error, it should be thread dot current thread dot interrupted. This basically interrupted will notify that okay, this thread was interrupted, so mark it as an interrupted exception and then do proper login. Sorry. So our process request method is ready. Now as for the active object design pattern, what we are going, in order to achieve asynchronously, we should run this process request method on a different thread, correct? So how do we achieve that? Is within the constructor of this bank account proxy class, we will invoke a new thread I use the help of thread class and pass in a reference to the process request method and start it. Correct. So this, when this proxy object will be constructed, it will continuously run the process request method on a new thread until and unless the request queue is empty. That's simple, right? That's what we have implemented. And because the request would then be delegated to the servant.deposit method, which is running synchronously, this would avoid race conditions. That's it. So we have prepared the servant component, the proxy component, as discussed in the previous theory. So let's now try to test this with an example. So here you can have a bank app, right? There would be a main method, and let's create a bank account object. Bank account object should be a bank account, should be a new bank account proxy. It's a new thread. Deposit, let's say 100, 110. We are not going to start this because internally it will start it on its own. Deposit another 30, withdraw another 50, right? So our main method will basically create an object instance of the account proxy class, and using that account proxy class, it will invoke those implemented methods which would be adding all this requests to our request queue, right? I hope it is clear. Before we go ahead and test this, try to add some of the statements, print statements. Bank app should be bank app running on thread.getName. Similarly, let's go ahead and add other methods. Out proxy created running on thread.getName. Then this is out processing request on thread.getName, depositing amount to bank account proxy on thread. Correct. Similarly, we'll add another statement. Withdraw drawing amount bank or thread this. Finally, under the servant class also we'll add some statements. This is out servant class thread, in servant class deposit method, in servant class deposit method. This would be plus thread. Correct. Similarly, we'll have it same for withdraw method, servant class withdraw method. Let's now test this. So for that we'll run it. Bank app running on the main thread. Correct. So firstly we see the sprint message is running fine, then it goes to create bank account proxy, then it gets the name and it tries to process the request on a new thread, right? Because of this new thread, but somehow our application is running in loop we'll have to first look at what is the issue. Statement is our main thread, so this is a thread name, it runs on the main thread, then it creates the bank account proxy, and the creation of bank account proxy is done by the main thread until this point, line number 12. From there onwards a new thread is created, so this new thread is printed from this processing request on the thread 0 will be the new thread. Then going back to the bank app, there is a line number 9, the line number 9, this one, line number 10, where a new deposit task is been added, request has been done. So it is basically saying deposit depend bank on thread number 3, so basically it is this one. Then there is a 50. Why? Because again this is a new thread, so adding the request, the bank account request is also processed through a different thread. So this basically decouples the method invoking. So method is invoked on a different thread and it now been executed on a different thread. Let's see how. First of all, this 4 task of deposit and withdrawal is invoked via different thread, right? Then in the servant thread, you can see the servant thread is the place where the actual processing happens. So the actual processing is done on a different thread, right? It's thread 0. Nowhere here is thread 0 in the invocation part. So this one block is basically invocation and this all is basically execution, and the execution is done on a different thread. So this is how this decouples and lets us to do asynchronous programming for multiple users. Let's just verify some of the calculations. So in the first request there is been a deposit of 30, right? So on a different thread deposit of 30 is done, then is again a processing request done, and then the process request a withdrawal is being done. So withdrawal is 50 and the new balance is minus 20. Does not seem right. We had done some implementation. I think the logic is not correct. So basically if the amount is it should be less than the balance, otherwise it would give insufficient funds. Let's rerun this. The logic was not correct, so I've just fixed it now. So see, the invocation is happening on different thread, then the deposit actual processing is on a different thread. So first request comes out for deposit, it makes a deposit of 110 rupees, so your final balance is 110 rupees. Then again another request is picked from the queue, this time the request is for withdrawal of 50 rupees, so it makes a 50 rupees withdrawal, so your new balance is 60. Then it again processes another element of picks another request from that queue, there it receives a deposit request of 30 rupees, so your new balance is 60 plus 30, 90. Then there is another processing request, the processing request is of withdrawal of 20 rupees, so withdrawal of 90 minus 20 is a new balance of 70 rupees. So this is how we are simulating a process of asynchronous calling of multiple requests, right? So this is how we achieve with the help of active design pattern, correct? I hope this is clear. It was very simple, and we go back to the PPTs, right? So we have done the completed the coding part of IntelliJ. I hope those coding practical examples were helpful, right? If you have any other doubts, please let me know, right? So understanding this active design pattern or active object design pattern is really important, because if you are a Java developer, this is commonly used. The active object design pattern is commonly used in many of the concurrent classes of Java JDK. Some of them are, it is heavily used in concurrent dot future task, and future task, which you might have known, it is very useful in many of Kafka applications. It is useful in many of asynchronous programming when you are doing multi-threading, concurrency. So that is one of the common example. It is also used in executor and executor service frameworks. Then if you are working on a swing application, it is heavily used on invoke and invoke wait later classes. It is used in timers, it is used in socket channel programming. So here are some of the common examples. Conclusion would be, while Java doesn't have a direct implementation of active object design patterns, a named construct in the JDK, but several concurrency related classes like feature tasks, executor surveys are using these principles of active object design pattern by decoupling the method invocation from execution and supporting asynchronous method execution, thus enabling us to implement and achieve goals of active object pattern, such as to do non-blocking asynchronous execution. So knowing this concept will be very fairly important and useful when you will be working on applications such as Kafka, or you might be using Java Kafka integration, when you will be using Spark application. So I hope we are clear with one of the other design patterns, and hopefully in our next video we'll discuss about another design pattern. I'm targeting to create another video discussing about completable features API also. So if you are interested in all these topics and learning different design patterns, please subscribe to this channel and hit like to this video, and hope you have understood the topics clearly. In case you are a beginner and have any difficulty understanding concurrency in Java, I have previous videos discussing about runnable and callable interfaces also in our functional interface series. So please go ahead and watch those videos once. And if you have watched till now, please hit like button and let us know for any suggestions in the video. Thank you. Have a nice day.